Well, and after the pause I made for technical reasons, as you heard, we continue about flight controls. It's our lecture before flight controls. About where we stopped at. We stopped at flaps and sleds. Do pay attention, I even highlighted. Movable sleds consist no idea why. Maybe here just some alphabetical mistake. No idea. Grammar mistake must be. Так, let me to adjust screen quickly for my tricky purposes in order and show and to check sound it's necessary. Sound working. After I wrote one, no, the whole lecture, like 1.5 hours without sound, I was about to cry. So now I'm just nervous each time and checking just in front of you whether it's really recording the sound or not. Let's come back. No, first let's come back to slides even. Flaps and sleds. Both types of devices, they are necessary during takeoff and landing. During both takeoff and landing, and they compulsory only move down. They move down and to a side a little bit, like these folder flaps and movable trailing edge, which move also a little bit front, down and front. What effect it gives, we have already seen. I permanently keep here this formula to remind you what it's necessary for. On one hand, changing the curvature of wing resulted in changing of these coefficients. These coefficients, they are necessary. They are necessary. No, yes, they are necessary. These coefficients describe changing of properties only. Yes, they are dimensionless ratios. They responsible, let's say, for changing the lift. Lift it's necessary during takeoff, sometimes more than for cruise flight, for horizontal stable flight. So on one hand, they increasing their lift. On other hand, to be frank, they also increasing the drag. And that is why we change position of flap and sleds different in different way, a little bit different way during the takeoff and landing. While takeoff, they are moved down significantly, but not completely. Some in the middle position, not approximately 10, 12, 15 degree for flaps. And when it comes about their landing, we interested in very high drag either in order to reduce runway after touchdown and in order to stop airplane quickly. That is why we move down and move out flaps and sleds much more significantly in order to have both lift and drag. Why we need increased lift during the gliding, I already tried to explain. We need to provide safety gliding, safety descending with significant reducing of speed. No, speed before, what do you imagine that airplane fly, what subsonic airplane fly with the speed around 800 kilometers per hour. And before landing, airplane need to reduce speed almost twice to 250, for instance, or to 300 kilometers per hour immediately before gliding. And while gliding, it's reduced even more the speed in order to prevent sharp motion to the ground, which will be too quick and may overcome, do forgive me, the speed of human reaction at all. In order to prevent crash, possible crash during landing, and in order to prevent extra loads to the structure of airplane itself, it's better to keep lift as much as higher in order to land safety. And for this flap, it's necessary to increase. But at some moment, immediately, practically before touchdown, you need to remove this, no, to reduce the lift at all, but still having the increased drag, which help you to stop. Difficult task. Difficult but solvable. For this task, we use so-called air brakes. These air brakes, they may be, we're talking about only flight controls. Braking it's possible by another ways, by different types of airplanes, but not for passengers, of course. For military airplanes, we also have special parachutes which are shooting down back while landing. Uh, Special hooks on the bottom, which maybe catch it by elastic element on the field or at the deck of airplane carrier. No, whatsoever. We're talking right now only about typical flight controls for typical passenger and cargo airplane. So we have so-called interceptors or spoilers. Why they called spoilers? Because really they spoil lift. We will see it right now. Now you see it already in a scheme. Here is these spoilers. Uh, Spoilers somehow no, somehow they are similar to one type of flaps where not all the surface was moved. What look to this split flap, no? But flap move down and spoilers always move up. I didn't find a scheme in this book, but we might see it immediately in a photo, very well visible. And these spoilers, or another name for them, interceptors. No, in English literature mostly I see the name spoiler. And why it's called like this, I already said, like literally it spoil the lift. When airplane already on height, no, meter, half of meter over runway, spoilers move up and the airplane just fall down really, like whoo, down. And due to this, it's touch runway, and additionally, these spoilers create additional drag. Yes, they prevent your motion forward. Plus, to this, at this moment, you already on landing gear, so you have some additional friction. Comparatively to the mass of the airplane, of course, it's nothing at all, so it doesn't help you much. But at least you have brakes in wheels additionally in order to reduce speed of the airplane. Quite clear that all devices are used in order to stop airplane safely at this moment. No, once again, it's visible. Look, spoilers reduce lift and increase drag during descent and landing. Uh, During gliding, no, this descent, it's gliding. Yeah, it's called gliding motion before landing and during landing itself. No, and in the scheme we have scheme is here. In the scheme we've seen it. They always move up. They are portion of the top surface of the wing. During the flight, they are hidden, just like hidden, like increase like the whole surface of the wing. You can't not even notice it watching the wing. And here in a scheme, it's shown like spoiler is somewhere at the end. It's not true because the spoiler may be no, it consists of some sections quite the same as the forgot flap. Flap may consist of some sections. Aileron may consist of some sections. When it comes about this length along the wing, along the span of the wing, and along the span of the stabilizer of the fin, the piece, no, for instance, like 1, 2, 3 there along. They are called usually sections, like inner section, outer section, and so on. Or immediately, like inner flap, inner aileron, outer aileron, no, and so on. And так, spoilers. we've seen. No, we have seen it. I hope we have imagined it. Due to pilot book is here. Due to pilot book, what it looks like, and seems like we have finished. Yes, let's check. Have we finished or not? Let's check with picture here. As I said, you the list of flight controls for one poor airplane. Look at this dreadful list. It's for one airplane, guys. No, there are two airplanes represented here. Boeing 737 control surfaces, Boeing 727 control surfaces. Let's check ourselves whether we have seen everything or not. Radar, elevator, we understand what is it. Tab. Or one more name is trimmer, servo compensator. What is it? I will try to explain a couple of minutes later. We have not talked about yet. Once again, look, stabilizer, horizontal stabilizer to provide stability of flight, radar, elevator. They are control surfaces to provide controllability of flight, maneuverability of flight, to make maneuvers during flight, rotations. Next, on the wing, the whole wing is not named. Great. No, because everyone understands that it's a wing. And next, on the at the ends, we have ailerons, and do pay attention, aileron and also tab, something like trimmer. Next, they have inboard flap, outboard flap, you see, or as I said, you inner, outer flap. Look at this. And inboard flap consists of one section, and outboard flap, as they call it, yeah, it consists of some sections already. Next, they have spoilers. What that is shown like in front of actually what the outer flap. It's from here to there and consists of couple of sections must be also. And there are three sections of spoilers, flight spoilers, and how they distinguish flight spoiler ground spoiler, maybe because flight spoiler is opened immediately before landing or before touchdown, and ground spoiler is opened at the last moment when you already on the land. I forgot to mention one more type of air brake. Air brake may be immediately on the fuselage, very similar like that. Oh, to imagine that one. But look, split flap. What do you imagine? Something like this hidden in the surface of fuselage, and it's open, like blowing at the end. Uh, Before landing immediately or immediately at the moment of landing, it's opened in order to increase drag. Exactly. There are another devices also, as I said, you both braking immediately mechanically, and also it's possible to use the thrust of engine for braking actually. Instead thrust pushing us, we may change direction of thrust while landing in order no, after you already land, after touchdown, in order to stop it. It's so-called reversing of the thrust. No, not right now about engines, not right now about this controlled thrust vectors, movable thrust vectors, only about the flight controls yet. And no, as for me, nothing much difficult here. They just give different names for what leading edge slats, as you might see, leading edge slats, leading edge flap. It's just depending on design of them. I hope you understood. But generally, they may be called just slats or movable leading edge. Now let's see the next one. It's even worse. Very similar wing by the word. Look, 737 and 727. Wing is similar. No, it's so-called commonality, inheritance of structure of family of airplanes. They are similar, but they are differ. For instance, with takeoff weight, because they design it for different amount of passengers, or they design it for a little bit different range, different distance from no, without landing. No, they able to do, and in this case, inner structure of airplane it's would be rather similar from point of view of design of technology of technologies, manufacturing technologies. It would be similar, and it's reduced both time while preparing the design project and while preparing the manufacturing facilities to provide program, manufacturing program. Quite clear that this approach, let's say, approach to design, it's for reducing our efforts to prepare the new airplane to the market. Так, once come back to the flight controls. Do forgive me a little bit jumping by by my speech. Stabilizer, elevator. Let's compare by the word. Stabilizer here. Not do pay attention. Stabilizer here is normal scheme. It's just on the fuselage. Yes, it's so-called middle plane. No, middle stabilizer. Here is low plane, so-called, because wing is below the fuselage, under the fuselage. And stabilizer comes through the fuselage, so it's mid position of stabilizer with respect to the fuselage. And here so-called T-shaped, what T empennage. You see, the stabilizer has appeared already at the top of vertical fin, of vertical stabilizer. Fin has rudder. There it's visible that it's divided. It's visible that it's divided onto some sections, both horizontally and not like along the vertical axis and along the horizontal axis, let's say, along the longitudinal axis, along the flight direction, it's divided. Altogether seems like four sections, but here they call it anti-balance. Look at this. Anti-balance steps. More probably, it comes about two sections of rudder and a trimming devices there. Stabilizer, elevator, and do pay attention also on elevator. They also have this, as they call it, control tab, some trimming surface. Why it's permanently jumping? What happened? Just to make me crazy. I know what is the reason. No, and the same on the wing. They have flaps. No, the most simple to find ailerons. Always at the end of the wing. It's not true. Because next we will talk about hybrid surfaces, hybrid flight controls. You will be surprised that maybe not quite true that they are always at the end. They are typical, as a rule, position of ailerons on their closer to the tip of the wing, on the end of the wing. It's difficult to say what is end, trailing edge or tip, because wing has two ends, seems like, along the span and along their, along the trailing edge. So aileron consists of maybe two sections, because it's called outboard aileron, and it means that somewhere it should be one more aileron, inboard aileron. Yes, look, what here is in another half of the wing, it's visible. They have rather weird story, but exist, you see. Aileron, next flap, and next aileron again, and next flap. It's to my word that they are always on the tip, closer to the tip. Not always, you see. So aileron, flap, how to distinguish them really in real structure mechanically? Usually it's visible. Usually it's visible that they are different mechanically when you watch it on the wing or under the wing staying immediately. And of course, when they are working, you will not mix up it at all. Once again, ailerons like scissors, up, down, one up, another down. And flaps only down, and depending on the landing and takeoff, they only down, but to different value of in degree, in different value, in different angles. What else? They have interceptors, spoilers, a lot. Look what here is: ground spoilers, flight spoilers, a lot. They have sleds and such weird name fence. No fence. It must be one of design of these sleds. No, 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 no. Fence. It's another thing, and it's given by name here, but it's not shown. What is fence? I will try to find you right now. Wait a second. Let's use так, mig. Mhm. Oh, what are aerodynamical fences? I hope it's visible. If not much visible, I will find the way to show you which one to take. Oh, let's take this one. It's of course not realistic, but very beautiful. What is this aerodynamical fence at all? It's the additional barrier, let's say, between sections on the wing. You see, it's follow to the airfoil. It's like along the airfoil, along the cord. And such a fence, what it necessary for? Usually, it's used on swept wings. No, if we start checking, like show me them, да, вот by any searching system, by any browser, show me airplane with fences. I'm just remember this one that it's has fences because it's one of airplanes. Place it immediately, no, like monument. Place it immediately in high. No, we have not MiG 15, we have MiG 17 immediately on the windows of my office in Hawaii. But you see, they are not much different. They both have fences, and these fences they are necessary to prevent motion of air from root to the end, like downwashing in along the wing may happen in case you have swept wing. If you wait a second, if you remember that beautiful picture where I show not me, but I placed two pictures together, like to show that ideal simulating in our imagination. It looks like, no, it looks like this in our imagination that ideal streams of air goes along the airfoil over and beneath the airfoil, but really it looks like this, and even not the whole truth is given here, because here you see the straight wing. No, it's tapered, but practically it's straight, it's not swept. When it's swept wing, these down washing things, they are directed like from root a bit, what from root to the tip with some deviation. And in this case may happen that oh, no, they spoil the washing in this place, and in this case may happen that the vortexes they are appearing out here, like bottom air. Here is, you do remember that here is the higher pressure, and here is the lower pressure, and there is some invisible barrier where they meet. This barrier really does not exist. It exists only in our imagination. And that is why here the higher pressure, no, like it was in Fowler slab, higher pressure tends to move air up over the wing. And in this case, of course, we have problem of vortex here. And do imagine that some portion of air additionally like streaming to this direction. And vortexes and drag will be. Ну что это такое опять? Something fly over again. Not so close like yesterday, no? Like black magic. As only I'm writing the record for you. Something should happen. And vortexes appear on the tips of wing will be responsible for additional drag. What is undesirable, of course, especially it's undesirable for maneuverable airplanes. Sorry, I'm start taratouring again, too quickly talking. No, I hope you understood what is fans, aerodynamical fans. Of course, not in all the structures we might meet them. It's rather specific thing, more typical for swept airplanes, for high-speed airplanes, and so on. No, quite the same. As I said, that flight controls are used, they are named, and so on. Not all the airplanes have such flight controls because variety of airplanes it's really great in design. And in order to illustrate my words, maybe I need to open. Maybe I need to open one more file. Wait a second, I'll do it. Until I do it, watch this. Так, it's for your group, the whole folder here with my old slides, new slides, and so on. What do you see right now? It's a table with possible decision for, for different, it's like for arrangement of different airplanes, a general arrangement of airplanes and existing technical decisions. Not all, of course, but the most important and the most usable of them are represented in this table. And I hope you do remember what did I what did I say about aerodynamical schemes. That aerodynamical scheme may be conventional, that one, wing, stabilizer behind the wing, along the fuselage. Canard, that one, wing is behind of stabilizer somewhere close to the nose. But look, there is the line of aerodynamical schemes. And right now, for us, they are not much different, maybe. But certainly you see that they are different, yes? And one of them has name tailless. Seems like no tail in this, no empennage in this scheme. No, really, at least it has a fin in tail unit group. Instead, the whole group, it has fin, typically, such airplane. But really, it has no stabilizer at all. But it looks at least like fuselage with the wing. That one it's called flying wing. It really looks like the whole wing without fuselage. There is no visible, notable fuselage in this scheme. Next, besides of canard and conventional, it may be, look, combined, you see, both conventional and canard. Some airplanes realize such a aerodynamic scheme when they have stabilizers in front of center of gravity and behind of center of gravity. Next, convertible. In English, it's koshmar at all, nightmare, because they are all similar in English sounds, like conventional, convertible, combined, canard. No, except of flying wing and tailless. Convertible, it means stabilizer appear and disappear during the flight. You may move it out and you may hide it. By the word, that airplane that I mentioned yesterday, airplanes actually, two airplanes, European Concorde and Soviet supersonic. It's always steam, hypersonic, sorry. Supersonic airplane Tupolev 144, they have convertible scheme of aerodynamical scheme with stabilizer, which is canard actually, but it's hidden during the flight, during the supersonic flight. It's hidden inside of the fuselage, like do you imagine this Jaga Jaga flapping down his ears? Where's the Jaga Jaga? That one. Now, what convertible scheme? What typical convertible scheme? It may move up and out his ears, да? and he may move it down. And in this case, like they streaming down, no, streamline it together with Jaga Jaga fuselage. Do forgive me. No, you understand what do I mean. By the way, what you see here is where prototype is elephant. Certainly, it's one of Mikoyan Grigoryev airplanes, if I'm not mistaken. Not clearly remember, really. That one, look. No, in case we have normal class, I would compulsory ask you how it's called this type of control surface or this aggregate. Of course, it's stabilizer. And MiG-23 also, I certainly remember, has a stabilizer. And MiG-21, they have stabilizer. But there is conventional scheme. Так, in order to illustrate my words, 21. Who, how to say it? Where we may notice it's stabilizer, it's not stabilizer. No, as for me, here is it's visible. Let's place it in the place where we may increase it. Look at this. There is, here is visible. Oh, whom it belong to. No, we bought it to different countries. So who is the owner of this? No idea at all. Whose flag this represented? Look, here is fin with rudder, you might see. You see it. And here is, looks like stabilizer, but where elevator is, because no elevator, because it's completely rotatable. And what here, how you behave? You make me crazy today, my dear computer. You see its slot already visible here, like stabilizer is moved down a bit from its normal position, and it's visible that it's really not stabilizer, it's stabilizer. And the same as MiG-23. And by the word, what at the end of delta wing, what you see now, the wing, so-called delta configuration of the wing, delta because after the Greek letter delta, it's maybe called delta wing, it's maybe called triangular wing, or whatsoever, you see it. It's certainly aileron, aileron on the rear surface, on the trailing edge, and flap. It's visible, yes? And what do we see else? We see a couple of aerodynamical fences, very little, tiny, really tiny, but they exist here. What is under the wing? It's not control surfaces. It's pylons for missiles. Фу, бяка какая. And no, all the military airplanes, they are purposed for this, you understand. What we see it right now in another photo, it's visible how they use these pylons. And under the bottom, by the word, it looks also additional pylon. And in this case, certainly we see not even weapon, I'm afraid. We must be see additional fuel tank. Not true, but I think it's like this. Let's come back to our story about flight control. Sorry, I deviated a bit from straight direction of my story, where it was here. So typical decisions, as I said, is like this, but really a lot of variants, and we need also to talk about hybrid surfaces. Wait a second, where we have been somewhere here. Да. No, in cross sections also it's represented in a picture. Show us, please. Now, what happened while flight? You see, no, they show different cross sections. Landing. What? Так. Landing flap. What we need to see it in comparison. I'm about to cry. No, I hope you see, guys. Top picture show configuration of wing cross section in different wing cross section. show it's in landing position while landing when we need to touch down, and take off position, next one, and cruise position when horizontal flight, you see. And to pay attention, what is the difference for no this inboard wing, outboard wing flaps, what they show fore flap, mid flap, aft flap, and so on. Do pay attention when you see while take off, you see that the no, it's so-called slotted Fowler flap, which moved out the wing and increased significantly, no, around like 20% at least. It increase the area of the wing to increase what? I permanently torture you with this formula. I'd like you to remember it during all your life. Sorry. To understand processes happened during flight, and at all to understand how airplane arranged and why it's arranged like this, what in its general outlines and general aggregates. Because increasing this area due to Fowler flap, slotted flap motion, you might increase area of the wing, and due to this you increase the lift during takeoff and landing. But do pay attention, while take off, when you need maximum lift, minimum drag, it's practically horizontal, it's increases the area, it's increases the curvature above the wall due to the slats. Also, you see slats, they are deviated significantly, but it's not to create much of additional drag. And during landing, in contrary, they do what? They increase both lift and drag. And that is why angles of deviating of hinged of this movable Fowler flaps, they are much more significant. Curvature is much more significant, of course, in order to increase this coefficient. And area much more significant, of course, to increase this coefficient, and drag also has been changed, you understand it. All these fore flap, mid flap, and aft flap, what is visible for you right now, I hope, it's to the matter how do they call how do they call these pieces, not along the span but along the airfoil. Look at this. Along the span, I hope you understood. It's called outboard, inboard, whether it's flap or aileron. And along the airfoil, they are called fore flap, mid flap, aft flap. The same will be with aileron in case aileron is divided onto pieces. No, never seen such a thing actually. I'm not pretend that I'm genius of aircraft history and I knew everything, but me personally never seen aileron divided on these fore, mid, and next sections. I've seen only like one piece. Flaps typically consist of maybe movable, maybe not movable. I mean along the airfoil, but at least they are rotatable, and they typically for big airplanes consist of at least fore flap and aft flap or main flap. Three sections like fore, mid, and aft flap. It's also quite typical decision for airplanes with with weight 50 tons and more. 50 tons, in order you may approximately understand what it comes about. Like yesterday, I gave you example with airplane assessing necessary takeoff and takeoff weight and necessary thrust for during horizontal flight due to airplane quality, predictable airplane quality. Does this ratio of coefficients lift and drag, and 100 of passenger for middle distance airplane. 100 of passenger means 12 tons of payload. because passenger plus passenger luggage and standard value is considered like 120 tons, and this 20 tons is around one quarter or one fifth even of payload. No, so 50 tons of airplane, it's approximately 100 of passenger. What airplane? It's a rather big airplane. Do you imagine? Well, next, I said we need to talk about the. Here is useful information, and useful in which meaning? Look, in cruise flight, we see how they are hidden. This stop jumping. How they are hidden these pieces of different flap, like they are all hidden and without any slots during cruise normal flight. Well, and I said you then there are some hybrid surfaces. What these hybrid surfaces for? Once again, mechanically, technically, aileron usually decided like it may work only when one control system is adjusted, designed like this. When one of them move up, another compulsory move down. But what if you have no place? You have no space. What happened? Oh, no, do imagine that it's very short space here. And it's mechanically difficult to place here. They propose to buy me airplane for $1. Funny. Maybe I misunderstand something. Maybe they propose to buy this picture for $1. No idea. Really. Beautiful place. Look what we have found. Maybe they mean to buy the model. No, I will not check what they propose. Once again, sorry guys. Look, delta wing, or let's come back to that possible aerodynamical schemes. This tailless so-called wing, when neither stabilizer nor even stabilizer is here. Yes, and or like flying wing, for instance, no tail group visible at all at this place. Or this convertible also, you see, in some cases it's not convenient. No, how we at all decide what area of aileron it's necessary. It's maybe too early for you in this explanation. No, how? No, we do understand what force we need additionally to apply either top, either bottom, in order to change position of airplane. Force depends on the area, and we need to spend some area of the wing at the trailing edge somewhere, but some area should be not less, or it does not work. Yes, the forces will be insufficient. And what if you have no such area in this place? You have no place both for flaps and for ailerons. What should we do then? And of course, in this case, people make so-called hybrid controls. They may work either as flaps during flight, no, during takeoff and landing. You do remember, I hope, that flaps used only during takeoff and landing, no, in normal flight. And ailerons, they are used for evolutions, for rotations during all the flight. So some portion of wing working only during takeoff and landing, I mean trailing edge, and some portion only during the cruise flight. In case this place mechanically engineering decision is more complex, in this case, system of controlling here will be more complex. So of course it's not desirable for all the airplanes decision. But in case you have such a problem, then you may combine these surfaces, but in one case they work like elevator, another case they work like aileron. And in this case, you do remember what happened with this name. Yes, stabilizer. Wait a second. Well, stabilizer plus elevator. And we have stabiliator. Movable, rotatable, completely stabilizer. And what about that one? Elevator And oi, oi, I thought too short time due to this. No, doesn't work. So simple. Please. Elevator and no, first is flap. Yeah? I've been talking about flap. Where it's written flap. Here is flap. Maybe combine it, as I said you, with aileron. Let's combine these words. And in this case, we have such hybrid control surface as flaperon. Not really written completely like this. Flaperon, easy to remember, flap plus aileron. They are placed on the rear surface of the wing. They are used as ailerons during the cruise flight and as flaps during takeoff and landing. So first they are flaps, next they are aileron during all the flight, and next they became flaps again. What is the difference? How they moved? Control motion on flaps resulted in moving them down to different angles, and control motion to ailerons resulted in the moving one up and other down. No? Decision more complex technically. I mean, metal decision in metal, but it's exist, especially for those airplanes which has not big span, short span, for instance, delta wing, or for airplanes of little size, it's quite typical decision. Certainly, for instance, why we use stabilizer, for instance, instead of stabilizer. If I'm not deleted that scheme, no, not deleted. Look, once again, how we decide what is the area of stabilizer should be. This so-called moment arm distance between center of gravity and stabilizer. The longer, seems like what, the longer, the better. Because in this case, you may place here less area of stabilizer. It will less force necessary because we need balance of moments, you understand. Moment of the lift with respect to the center of gravity on one hand, and moment of stabilizer to another side, yeah, with the center of gravity. The more arm of moment, arm of force here, the less stabilizer is possible. Whether it's good or not, the stabilizer will be less. Of course, it's better because it's stealing the lift. In this conventional scheme, it's responsible for stealing the lift. Together with this, it has weight. For this weight, we need additional fuel, no, and so on. The whole chain of problems appear due to this stabilizer. But we can't live without it. That is the problem. And what if airplane is little? It's some not even business airplane, but some so-called general aviation airplane. Very, very little, very funny, so sweet, so funny usually, but they are short. Practically, there is no distance between wing and stabilizer, and in this case, you can't. No, the whole stabilizer practically should be equal to the whole elevator. Either you place the huge stabilizer, which with elevator, or you are forced to use all the surface of the stabilizer as elevator time to time. Well, in such a way of appearing of these stabilizers actually. Usually, as I said you, in case of too short distance here, non-sufficient distance, and usually it happened to light airplane, to little airplane of general aviation, and to military airplane, maneuverable airplanes. Like we have seen it in Mikoyan and Grigoriev MiG-21, MiG-23, and so on, stabilizer. The same story, flaperon, how it's appear. If you have configuration of the wing, which doesn't give you place where to place both type of surfaces. In this case, the same control surface have to work as time to time flap, time to time aileron. And one more type of such a surface exists. Так, that I said, flaperon, elevator, stabilizer. Ой, when flap combined with elevator. Guys, really, right now already losing my mind. The flaperon, flaperone, elevone. Oh, elevone. When elevator combined with aileron. And that is typical for tailless airplanes. Elevone, look, like this. But piece of word elevator we will delete. This one we delete. This one we delete. And altogether we have word move it. Elevon. Elevon is combination of function in the one surface, elevator and aileron. You understand, I hope, why I do these tricks with summarizing, removing the words in front of you, in order you may remember these names, like intuitively. Once again, stabilizer plus elevator together, merged together, is stabilizer. Flap and aileron merged together, no, like the same control surface, fulfill two functions time to time. Flaperon and elevator merged with elevator is here, no, in our picture, and aileron is here. In case we have tailless airplane, more probably it will be elevon. It's merging of elevator and aileron in the same surface. So time to time they used like ailerons, move up, move down, and time to time they use like elevator when both of surfaces hinge either up or down. My dear people, I over time it again. Sorry, let's switch off record and meet next time.